SwayamPrabha. Digital India. Educated India.
Hello, welcome to Introduction to Composites. Today is the last day of this particular course, and what we plan to do today is have a very brief overview of how to predict failure of composite laminates. That is one thing we will do, and then we will have a formal overview of whatever we have discussed in this course. So, we will start our discussion by talking about failure of composite laminates. Failure of composite laminates. So, the purpose of this discussion is to develop an approach that if we follow it in a methodical step by step way, we know that at what load which particular layer is going to fail. Okay. And once that layer fails, then what happens to the composite if I keep on increasing the load further. This is what I want to discuss. And the way to address this question is by following a step by step process. So, predicting failure means first calculate A, B and D in each for the entire laminate. That is the first step. We have to calculate A, B and D. Second, if N and M are known, then calculate epsilon and curvatures in each for the laminate. We have to find the mid plane strains and mid plane curvatures, and this is only if we know N and M. If we do not know N and M, then we cannot solve this problem of failure. So, we have to know N and M. Once we calculate the mid plane strains and mid plane curvatures, then we find sigma L, sigma T and tau LT in each layer. How do we find it out? Once we know epsilon naught and curvature, for each layer we can calculate strains in each layer, because strain vector is equal to mid plane strain plus Z times curvature. So, for each layer I can calculate strains in the x, y and shear directions using this relation, and then using this thing I can transform these strains in the LT coordinates. Once I have converted them in the LT coordinates, using the Q matrix I can calculate sigma L, sigma T, tau LT in each layer. So, I have to do layer by layer approach. Okay. Then the next approach step is that we use some criteria, for instance the Psi-Hill criteria. So, in this case we will just say use Psi-Hill criteria to see if each layer is safe. So, we have to do it at every single layer, we have to apply Psi-Hill criteria. We have to compute sigma L, sigma T, tau LT for each layer, and then for each layer we have to use Psi-Hill criteria to make sure that whether it is safe or not. And then if all layers are safe, then we are okay. Then we are okay. Otherwise, if some layers fail, if some layers are failing, then what do we do? Then what we do is, so we will see that the Psi-Hill criteria will be violated by a maximum extent on some layer, in some other layer it may not be violated by that great an extent. So, the layer in which it is failing first, that is the layer we will consider that it will break first, where it gets violated first. If some layers fail, what we have to do is identify which layer fails first. Okay. So, let us say that is the kth layer. Let us say this is the kth layer, it is failing first. Then we go back and for kth layer, so we know that kth layer is going to fail first. So, we say okay, as I keep on increasing the load, kth layer is going to fail first, but I am still increasing my load. What happens next? Once the kth layer fails, what does it imply? Its Q bar matrix, it becomes 0, because when it has failed it cannot take any more load. So, if its Q bar matrix becomes 0 and then we recompute A, B, D for the remaining laminate, and we go back, we again find sigma L, sigma T, tau L T, and in this way what we will find is that we will see progressively as I keep on increasing my load, first one layer will fail, if I keep on then another layer will fail. So, in this way I will be able to predict the sequence of failure of layers in a step by step process. So, it takes a lot of time, but if you follow this method religiously and in a very disciplined way, you will be able to predict how the laminate is going to fail as I keep on increasing the load on it. Okay. And in terms of its stress strain response, the failure, so suppose I have a plate and I am just pulling it. So, I am applying some sigma, and because of this there is some strain in it. If you plot its stress strain response, and suppose there is no coupling between bending and extension, then initially it will be a straight line, and we are assuming that it is a linear elastic system, and then the first layer fails. When the first layer fails, what happens? One of the Q bar matrix becomes 0, and because of this its overall stiffness becomes a little less. So, the slope changes, and then the second layer fails, then the slope changes further, and then the third layer fails, and after a certain point this slope becomes either 0 or negative, and the moment that happens it means that the plate cannot take any further load and the whole thing will collapse. Now, this is using principles of linear elastic theory. In reality, the curve is something like this, but the blue line will give you a very good idea as to how layers are going to fail in a series of progressions. So, this is the basics of progressive failure layer by layer failure in a composite laminate. So, this is what I wanted to talk about, at least in context of failure. We will not develop any detailed mathematical models for this, but this will give you some basic idea and it will get you going in case you really want to figure out how these layers fail in a progressive way. And that concludes our discussion for this course. This has been a 12-week course, and over this course we have discussed a series of topics, and we started our discussion by talking about composites, what are composites, what are different types of composites, their classifications. Then we also discussed different types of fibers, matrices, their strong and weak points, their manufacturing methods, different types of additives and fillers which go into composites. And once we had discussed each of these different materials, we started discussing different manufacturing methods for different types of composites. And once the manufacturing was over, then we started discussing how to predict the properties of unidirectional lamina if we know the individual properties of fiber and matrix materials. So, we developed models which now help us compute EL, ET, GLT, Poisson ratio, nu LT, and also the failure properties, right, sigma LU, sigma TU, and so on and so forth. So, that was for unidirectional composites if the direction of force and the material axis were mutually aligned. Then we made this a little more general, that if this alignment was not present, then what do we do? So, in that context we started looking at the elasticity tensor, and from 81 constants we were able to show that for in plane isotropic condition, or for the situation when we have a plane stress state, the number of constants required for a unidirectional laminate is 4, and using that simplification we developed different stiffness matrices, Q-bar matrix, and using that we developed relations for A, B and D matrices which influence the mid-plane strains and mid-plane curvatures if a composite plate is loaded by force resultants and moment resultants. And then we have discussed different lamination sequences, and today we talked about in very basic progressive failure theory for laminated composites. So, this is pretty much the conclusion of our discussion in this course. We will have a formal exam on the dates which you already are aware of. You already know the format of those exams. So, please prepare for those. Again, all these exams will be multiple choice questions types, but you will have to do some detailed calculations for solving the problems which you will see in the examinations. So, please do review everything what I have taught you, and if you do a detailed review and work diligently, I am certain that you will do well in your examination. Some of you may also be interested in an advanced level composite course. So, I just wanted to tell you that next semester I will be offering an advanced level composite course which will be a development on whatever we have discussed till so far. Specifically, what I will cover in that course will be 3 or 4 important themes. One is that what are the differential equations which govern the behavior of composite plates. Till so far we have assumed that if the value of n and m is known, then I can calculate mid-plane strains and mid-plane curvatures, and that basically assumes that external force and moment resultants are known and they are constant. But if it is a variable loading condition, then what do we do? So, in that context differential equations become important. So, I will talk about those, and then we will solve some real life problems involving beams, plates for different lamination conditions, boundation conditions, loads, temperatures. So, that is one part, and then we will also do the same thing on plates. We will also see at what loads plates buckle, how can we predict bending of a plate which is loaded uniformly on its entire surface area, and so on and so forth. The second important theme which I will cover will be short fiber composites, and there we will discuss both oriented composites as well as randomly oriented composites. So, that is another one, and then of course, we will discuss in detail about this progressive failure theory for laminates. So, and we will also talk about hygrothermal and temperature induced stresses and strains in composites. So, these are 3 or 4 broad themes which I will cover in advanced composites, and of course, we will start with having a good review so that people who are new to the course will also not feel handicapped. So, that concludes our discussion for today. I hope that you had a wonderful and enjoyable as well as an educational experience in this course, and I wish you best for your future and look forward to seeing you in the next semester as well. Thank you.